Boom! What's up, everyone? Welcome to Simulation. I'm your host, Alan Sakyan. Super excited to be talking about the chemistry of consciousness. We have joining us Mike Johnson, Andrés Gómez Emilsson. Hello, you two.
Hi.
Thank you so much for coming on the show. Mike, pleasure to meet you finally in person.
It's good to be here.
Thank you. And Andrés, thank you for coming out for number 2.
Thank you.
I love it. I'm so happy to meet your co-founder of Qualia Research Institute, Mike Johnson. Very excited. Also, Mike's an author too of Principia Qualia, which is very exciting. And you can actually find this on the web as well.
That's right. My website, opentheory.net.
On opentheory.net. That link's in the bio. And as the co-founders of Qualia Research Institute, you guys have been doing this for 4 years. And previously, you guys also both blog at Qualia Computing and at opentheory.net. And those blog links are below. The episode 1 with Andrés is also below. You can watch us unpack Qualia and unpack consciousness and unpack so much more valence. We're going to get into all of this. I'm very excited. Mike was also previously doing hedge fund work as an advisor, doing a bunch of stuff there, 13 years of that or so. Yeah. Ish. Okay, cool. So that's a bit on the intros. We're going to get right into, we have some great images to unpack with you guys. Okay, we start off with this big history perspective on what's happening here on this playground, Earth.
Right.
And we're kind of passing the torch from a biological intelligence to a non-biological intelligence. So give us your take on the synthesis.
Right. So there is, it seems like there is this transition coming where we're sort of creating this new thing. We're calling it AI. And right now we're in the driver's seat. That may not be the case forever and ever. And there's this question of what kind of future we want to live in, what kind of future we want to build, or what kind of future we want AI to build. And so I'm very interested in the AI question, in how to pass the torch in a safe way. My current opinion here is that we're pretty confused in terms of what we're actually trying to do with AI, other than not have it kill us all or whatnot. And I think consciousness research, and this is kind of an odd statement here, but I think consciousness research is really the antidote to a lot of confusion in the AI safety space.
That right there is even a powerful statement.
All right.
Yeah. That consciousness research is an antidote to a lot of the confusion in the AI safety and security research space. Those words aren't said that often.
Right.
Yeah.
Right.
Yes. Please continue. Yes.
Yeah. So Nick Bostrom in his book Superintelligence talks about one of the failure modes of something that could go wrong, and he says that it could be that we sort of trade off what makes life valuable in the pursuit of optimizing for intelligence, optimization for capacity. And his metaphor here is that we may end up building a Disneyland with no children.
Yes. Yes. This is a very powerful metaphor.
All right.
Yeah. Disneyland in this case being a super intelligence that is able to go and enjoy itself in the cosmos, and then without children being without qualia, without feeling or experiencing the Disneyland.
Right. If there isn't anyone to enjoy the Disneyland, then what's the point? And so this is why, one reason why I'm very passionate about sort of getting to the bottom of the mechanics of subjective experience. what has it, how it all works.
And this is why you're co-founders.
Right.
This is why you guys partnered together. Yeah, this is a great sort of, it's awesome that you two, and here's the QRI logo too, which is so cool. It's my first time actually seeing the logo. We didn't have it for the first episode. It's a great logo. It's cool that you guys found each other by you coming and seeing this as a main issue of civilization, and then Andres was doing the transhumanist Stanford's event. There was an event that you were producing.
Yeah.
And you founded or co-founded.
Yeah,
co-founded the organization.
Yeah.
And then Mike came to the event, and then you guys met.
Yeah.
Right.
Okay, so that's that origin story of how you guys met. And then also the online that you guys were seeing that someone was saying something about.
Yeah, and the moment I met Mike at the event, it's called Advancing Humanity Symposium at Stanford. He came up to me and says like, "I know what pleasure is."
He thought I was pretty weird at the time, but
I thought like, hey, somebody thinking about this problem is probably pretty valuable.
Right.
Yeah.
I was very skeptical of his particular solution, but I think like, hey, like building precise, empirically testable
Yes.
hypotheses for like what pleasure and pain is, what conscious value is itself like an extremely valuable thing. And like I thought like, oh, maybe he might be wrong on the specifics, but like he has the right idea of like producing these testable predictions.
Yes. That what are the both chemical, computational properties of pleasure so that there can actually be children in Disneyland.
Yep.
right.
Okay.
And children having fun.
And children having fun. You call it super happy, super intelligent, and super longevity.
Yes.
Children having fun. Yes. Yeah, because that is what the God or the experiment or whatever you want to call it would want as the life to evolve to. I think as a pinnacle. Okay. So yes, Ron. Okay.
Careful with the God.
Yeah. Or all that is the creator, whatever you want to call it. Yeah. Because why would there be the Disneyland without the felt experience of pleasure to the max? Yeah. Okay. So now we have this project, Qualia Research Institute. So this is how you guys do the framework of understanding the new science of consciousness, and then understanding qualia. We'll get to that, and actually how to
Yeah, that's right.
And we have some images as well as we go for
Great.
this. Yes.
One frame that I like to put this in is alchemy used to be a thing, and clearly something interesting was happening, but everyone was very confused about how to talk about reality in this context. And they tried to turn lead into gold, and they were able to do some things and also wasted a lot of effort. Over time and with a lot of effort, chemistry sort of arose from this field of alchemy, and we started to be able to make very clear sense of what's going on and frankly what exists as well. And what QRI is doing is we're working to basically turn consciousness from alchemy into chemistry.
Okay, so I'm envisioning us over thousands of years figuring out how to make into the world using the periodic table and etc., and discovering the periodic table and all of the different actual
Right.
elements, etc.
What are the corresponding things that we would expect to sort of discover or explore in consciousness research?
What is the periodic table of the mind?
Absolutely. Perfect.
And how to combine the basic elements in recipes in order to generate arbitrary states of consciousness in a precision engineered way.
Yes. Okay. All right. This is very good. All right. Okay. So we are doing to the mind what we did with the periodic table and elements. So now we're doing it to the mind, and we're going to figure out the catalog of experiences and how to precisely engineer those experiences. Okay, and then we're going to embed that in the passing of the torch.
It feels very important that the process of passing the torch include this knowledge.
Yes.
Because otherwise, it doesn't feel like it would lead to anywhere good.
Yeah. Okay. All right. So to the new science of consciousness image.
Yeah.
Okay. All right. Let's pull up that first image on the new science of consciousness.
Yeah, so these are kind of we call it kind of like the 8 problems for a new science of consciousness. It's kind of like a misleading to think about like the problems of consciousness in terms of the hard problem, right? Like Chalmers famously coined that term in terms of like, hey, if there's only, structure and behavior in a brain, like where does subjectivity come from? And if you frame it that way, it's an insolvable problem because you start out with the wrong ontology to begin with. On the other hand, if you actually decompose the problem into a sufficient number of good sub-problems, you can get a big picture that if you are able to tackle each of them independently, you will get the solution. An analogy to this is like, for example, like in the 18th century, people were thinking about like, the hard problem of matter. It's like, that's not a very useful way of thinking about it, right? Like matter turns out to have like, 4 different fundamental forces, and you need to really decompose it into a lot of sub-problems and tackle them independently. So in terms of like the problem of consciousness,
you have a metaphysics, a math, and an interpretation.
Exactly. So like metaphysics, roughly speaking, is like what aspects of reality basically corresponds with consciousness. And that will involve things such as like, is consciousness a computational phenomena? Or is it an algorithmic phenomena? Or does it have to do with the actual physical energy? And that's kind of like to identify what parts of reality corresponds to consciousness. And that really is a metaphysics problem, but has precise empirically testable threads that you can pull to. Is not just like armchair philosophy. You can actually dive into and figure out precisely what it is. Then you have like the math, which is like, okay, you identified, let's say like that a certain type of feature of reality is what underlies consciousness, whether it's like algorithms or physical energy or whatnot. Then you have the problem of, what defines the boundaries of experience? If you have a system, what parts of that system are actually contributing to the experience that the system is instantiated? That's called the boundary problem, also called the binding problem of consciousness. And then, you define the boundary of a particular state of consciousness. What does that state of consciousness feel like? And to actually get an answer to that, what you need is to understand basically what is like the state space and the topology inside that boundary that maps to states of consciousness. So identifying what part of reality corresponds to consciousness and how to create a boundary around it doesn't fully solve the problem. And that's actually where a lot of theories of consciousness basically end.
Kind of like the question of if consciousness is localized in the mind, and then the next kind of step is this topology of experiences that the mind can produce.
Yeah. I mean, just to give you an example, I mean, it's true. Like that would be part of the boundary problem, right? In some views, you could be like non-localized. Let's take for example the global workspace theory of consciousness. It basically says that on any given moment in time, there's a set of neurons that basically are talking to each other, and is like the largest set of neurons talking to each other in the brain. That maps to your state of consciousness. And maybe there's like some little islands of neurons that are chattering, but as long as they're not immediately contributing to the largest bundle, you want to be like conscious of them. Now,
so is this quite literature solid, testing solid, that we've had instances where when you're mapping neural activity, that you've seen like a big amount of activity which you could call the conscious felt experience in that moment, but in a separate area of a little bit of neural activity happening somewhere else, but that is potentially not part of the
one sort of a clear example here is that there are a lot of neurons in your stomach, but you don't feel what's happening in your stomach except through the nerves which connect your brain.
So the vagus nerve we can be feeling hunger, and that you could say then is me be consciously experiencing the neurons potentially.
You may be, I mean, that's actually pretty tricky and controversial.
Okay.
A very likely possibility is that actually the phenomenology of hunger is still within your brain.
Okay.
It's just being triggered by the neural impulses from the stomach.
Okay.
And we know that that's true because people with like damaged vagus nerves, you can still stimulate some areas of the brain to make them feel hunger. So it's not like you actually literally need those neurons there.
Okay.
So that corresponds to like the boundary problem. But then you still have the problem, okay, like I've defined the boundary, okay, like these sets of neurons interacting in such a way. How do I translate the structure of those neurons interacting with each other into what state of consciousness the person is in?
Yeah.
Like, are they experiencing hunger? Are they experiencing pleasure? Are they experiencing the color blue? And so on and so forth.
Yes.
And that corresponds to the interpretation problem.
Yeah. There's a lot of data. That's another one of the major things is that,
Right.
I think there's something nuts that, it's like 90% of all of the data humanity has ever created was created in the last 2 years. And then now our biggest problem is structure. It's like 90% of all the data is also unstructured data. And so now when you're trying to, this is basically data. And then, how to actually, make sense. You're tackling one of the most important, hardest projects.
Yeah. It is this issue of, okay, consciousness is this very difficult problem. Where do you even start? And we think this sort of maps out where to carve the problems.
Yeah. Okay. And I mean, this is why this is episode 2. There will need to be more times of unpacking this. But we have so much still to go on to. So let's go on then. Okay. All right. Let's go on then. All right. So now teach us about valence.
Yeah. So the question of where to start, you basically want to find the simplest kind of qualia. You could say this is from Dan Barclay, the C. elegans of qualia. Just the simplest model organism, so to speak. And something that exists in a real sense. It isn't a leaky abstraction, but it's some part of the fundamental features of reality. And we believe that the way in, I guess one metaphor would be the first line in the Rosetta Stone of consciousness would be start with valence, start with pain and pleasure.
Interesting. The first line in the Rosetta Stone of consciousness is start with valence, pain, pleasure. Now, you have this triangle, pain in red, pleasure in blue, and neutral in white. And then all experience can fit.
All experience would have a valence associated with it.
Yeah.
And so how we're setting this up is, so if consciousness is real, then one way to reframe that is it can be represented by some mathematical object. So what it feels like to be Alan's phenomenology could be represented by a mathematical object. And then some part of this object, some pattern or property of this math object would correspond to how pleasant or unpleasant it feels to be you.
Okay. And now, what would this mathematical association to my felt state look like?
And when just a very clear example of like a mathematical feature of an object, like for example, how people used to think that, like, what is temperature? Right? It's like, oh, temperature, they used to have like this caloric substance, right? It's like, oh, maybe when you heat up a cup, there's caloric substance inside it, it just spreads out afterwards. But then people figured out, hey, like actually the average speed of the molecules corresponds to the temperature. So basically that is a mathematical feature of that object that gives you these like essentially one-dimensional aspect of it. Except in valence is really 3 dimensions. There's subtle complications there because basically on any given point in time, you could locate your experience in any of the space defined by this triangle. So most of the time you're not experiencing pure pain or pure pleasure or pure neutral states. Most of experiences are mixed. You know, and you could imagine like a super extreme mixed experience is like, okay, let's say you're enjoying like music in a concert, but also like there's like something very dissonant in the background and you're dealing with emotional pain and, you know, this very complicated state. That would be maybe kind of like up there, like in the middle, right? It's like a lot of pleasure, a lot of pain at once. Whereas let's say like you've been taking antidepressants like SSRIs for like 10 years and you're the type of people for whom SSRIs have a neutral hedonic response. So basically they narrow the range of the pleasure and pain. Maybe you would be in that extreme of like, oh, things don't feel neither good nor bad. They're just kind of meh or whatever. But most of the time you're kind of like somewhere in the middle. You're kind of like moving around in a little bit of a Brownian motion over there.
The vicissitudes of life, these ups and downs, even in a single experience in a location, you can be going between oscillating between your I love being here with all this to like I have so much stuff that I need to do or whatever. And so okay, now mathematically you started indicating that this can be like heating up the way that atoms are moving in
exactly
water.
Like if you identify the mathematical object whose features are isomorphic to the features of your experience, we basically predict that like in that object there's some math you can apply to it that will output where in that triangle you are, or where in that triangle that object is, which is you on a given moment in time.
And so this really speaks to what knowledge would look like about qualia, about consciousness, about phenomenology. That if you went to sleep for 100 years, then woke up and wanted to figure out, oh, I wonder if they've solved consciousness yet. So you went to the bookstore and just kind of flipped through Qualia 101.
Got the download.
Exactly. Then one way to think of it would be knowledge about qualia would be sort of in a table. And on one side of the table would be mathematical properties.
Mathematical properties of pain, mathematical properties of pleasure, mathematical properties of neutral, and then all the nuance.
Well, I would say math on one side and phenomenology on the other side.
And then math and phenomenology make that pain-pleasure spectrum.
Yeah.
Okay.
Right.
Okay. Yeah, because the phenomenon and the math will locate you on this.
Yep.
Okay.
Yeah, and so really reverse engineering pain and pleasure would be trying to figure out what mathematical feature they might map to.
Yes. Okay, so now let's talk about this. Okay, so we were indicating this earlier. There's some neural activity happening, and we're reading it with maybe instead of the blobby like fMRI resolution, maybe we have some sort of a really powerful signal from an electrode that we've, etc. And we're just reading it right there. Let's say the billions of neurons or whatever the number may be that we're reading right there. Now, how would that be math?
You need to transform those physical readouts into the appropriate mathematical object. And you could make a huge mistake there. I mean, like if you think like the mathematical object is, let's say, like a certain type of algebraic ring, okay, maybe you're completely wrong, and like whatever transformation you do is not going to work. Maybe if it's a manifold or field, okay, maybe that's where it's at. And right now there are some interesting candidate mathematical objects that we're exploring, and maybe we can go into them.
Okay.
Yeah.
Is that next?
Yeah. I think so.
All right.
Yeah.
Let's do it.
I mean, this is the work of Salin Atasoy and some other people. Basically, they're taking neural activity, specifically in the form of fMRIs and tensor diffusion imaging. So they basically map out the shape of your brain. And based on the shape of your brain, white matter connections, gray matter connections, they apply this equation. It's called like an excitatory inhibitory wavefront that basically simulates how excitation and inhibition will propagate in the brain.
Okay.
And just as anything in the physical world, anything with rigidity
Yes.
has like resonant modes, basically ways in which a wave can travel an integer number of times and the pattern repeats and doesn't cancel each other out. The brain also has harmonic resonant modes, and there's a discrete number of them. So it's like, rather than thinking of it as like, just a lot of neurons firing in this complex, chaotic, indescribable way, it's like, you could actually describe all what's happening in the brain, or a big chunk of what's happening in the brain, as a weighted sum of various harmonic patterns.
Of harmonic patterns. Okay. So what's causing it to excite or inhibit those neurons?
And one sort of simple frame on this is that just like a guitar has natural resonant patterns,
Yes.
Frequencies that naturally resonate within the guitar, and a piano would also have natural resonant patterns. So too the brain would have them. And we're suspecting that this will be an interesting way to proxy phenomenology, and especially the texture of phenomenology, how experiences feel. Maybe I'm skipping ahead here.
Okay, let me ask then, because I still want to understand. A harmonic is a very interesting way to think about this.
Yep.
Okay, so, and the connectome is the full mapping of everything.
Of every, especially like neural conduits and fibers.
Conduits and fibers.
Like the reason why they're so important is because the waves travel through them. And then also the reason why you actually need to differentiate between the white matter and the gray matter is because the waves travel faster in the white matter.
Faster in the white matter.
Yeah, so you could imagine like if you have a table that maybe in like the core.
Interesting. And the cortex is gray matter.
Yes.
Yeah. Okay.
Travels slower.
Slower. Interesting.
So like
more potentially primordial infrastructure is traveling faster. Maybe.
Yeah.
Sometimes.
Yes, the white matter is associated a lot with like sensory processing and things that you need a lot of kind of like fast reaction time, whereas like the gray matter is like for things that are like slower.
Okay.
So the analogy here is like if you have a table, it's made of iron.
I just imagine you doing the meme.
It's like, let's say it has like it's mostly iron, but it has like an aluminum core. The resonant mode of the table, like if you hit it with a hammer and you listen,
yes.
The fact that the center is made of aluminum will change what notes it can play, because maybe the waves will travel faster there. So you need to take into account basically the speed of the wave propagation and doing so in a fairly differentiated way, so you can actually simulate and see, what are the harmonic resonant modes.
Okay.
Everything makes sense so far?
By everything. Yeah, like 0.01% for sure. Yeah, kindergarten level, always. Yeah, stuck in continuous kindergarten of the universe.
as are we all.
Yes. It's picking up. Episode 2 picks up a little bit more. It's like the slow pickup.
Right.
Okay. Yeah, I know we need to move on. I just love thinking about it like a harmonic, because there are also, if we can potentially say, you can maybe apply that Pareto principle, that Pareto distribution, to harmonics as well, and say that potentially that only 20% of harmonics that we can map account for 80% of the felt experiences.
Yep.
And then those 20 are very important to then go first for this, like the lowest hanging fruit. Yeah, and that might be things like the extreme pleasure or the extreme pain, and where that is, and mathematically getting to that.
Yep.
Okay.
Yeah, and just to say a little bit about why we're focusing on this sort of analysis of the brain. There are a lot of different ways of looking at the brain that don't seem to say much about phenomenology. For example, which brain regions are more or less active. It's something that we look at because we can gather the data easily enough with fMRI, but it doesn't seem to be useful in a lot of ways. We can find interesting correlations, but what do they mean? Likewise, we can measure different energy in different EEG bands, but again, what exactly does that mean? We think that this harmonic analysis of the brain is especially interesting because it's not exactly measuring phenomenology. It's not exactly measuring the texture or context of emotional or subjective experience, but at the same time, it's much closer. It's sort of, it's plausible that when this changes, when your brain's resonance changes, then what it feels like to be you will also change in interesting ways.
And then if we have a subjective, if we have a humans subjectively explaining what is happening while they're being mapped to that degree, then you have millions and millions of those examples, then you can start saying that this
can build the data.
Build the data. Okay, so now move. Yes. Okay, on we go.
Yeah. So, I mean, this is kind of like a toy model.
Okay, blah.
Oh yeah. I mean, this is, remember the valence diagram?
Valence,
right?
like, neutral, pain, pleasure.
You're pretty close to neutral, for example.
Okay. Oh, I see. Okay, that's where there's a dot there.
Yes,
and
exactly.
And that's why it's okay, blah, meh.
Exactly.
Uh-huh.
That's an example. There's other pictures with different shapes, but
versus ecstatic in the top right corner.
Yeah.
And exactly. Yeah.
So we may have kind of buried the lead here in that what QRI has is we have a method which we hope to get some data on soon to basically put somebody in an fMRI machine and objectively determine how happy they are.
Mm-hmm. And that'll be for potentially the next episodes we can talk about this.
Yeah.
Okay. How soon and how many people will be doing this?
Right. I mean, we can go a little bit into the details of that. So
yes.
I mean, this is one of
as
the
much as you want.
No, for sure. One of the crazy things is, like philosophy of mind, right? Like there's thousands of papers published every year. But how many of them are generating precise empirically testable predictions?
Yeah.
Maybe half. I mean, it's really rare actually to have
replicability. Replicability.
Yeah. Yes. What we have in here is, hey, from first principles, we are postulating that the mathematical feature that corresponds to valence of the mathematical object, that is your consciousness, will be its degree of symmetry. And symmetry here is defined as invariance upon change. So basically the ways in which your brain is transforming that object, how many of those are leaving it the same. And we think that that's going to be like the key for understanding basically how pleasant or unpleasant your state is. With Selinatasoy's work, where you decompose the brain into its harmonics, it falls out of the math that basically to quantify the symmetry of the state, you can basically apply a very similar principle to how to quantify the harmonic signature of sound. Basically, you quantify how dissonant it is.
Like a cymatic?
Yeah.
Okay.
Like, I mean, if you play like 400 hertz and 450 hertz,
yeah,
that tends to sound rough and unpleasant. And one explanation is that basically you get like these beat patterns that within the window of attention they don't repeat. So basically they just keep your attention in its toes, so to speak. Likewise, if you add brain harmonics that are like nearby, like let's say like, oh, this is a 20 hertz harmonic, this is a 21, you add them together, the whole shape is going to be discombobulated. And we predict that that's going to be really unpleasant. And on the flip side, on really pleasant states, I mean, consider like MDMA, for example, we predict that
psychedelic.
a good trip.
Yes, the very good trips. Yes.
Or MDMA for like a robust high valence
We
effect.
highly recommend psychedelic assisted psychotherapy. If you, yes. Shout out to MAPS as always. We
Yes.
love you very much.
MAPS.
MAPS.
We predict that MDMA states are actually going to be highly resonant and highly consonant. So like the reason they feel good is because the harmonics actually add up together in a very synergistic and symmetrical way. And that's completely testable. And again, it's not that we have actually looked at the data and inferred this. It's more crazy and daring. Is saying if our theory is anywhere in the ballpark of being true, this is what we're expecting to see if we conduct the experiment.
And then how again do we get the math of coherence? How do we,
Right. So, I mean, this is essentially a way to quantify the harmony in a brain. Coherence or consonance / harmony, all these are sort of related concepts. So the algorithm, and Andres can also chime in here, but it's basically looking at each brain harmonic. So all of these in the circle are different resonances in a brain, in a single brain. And so
And what's the difference between the small black dots, the big black dots, the red area on the left, and the blue on the right?
how much energy there is in each harmonic?
The black dot is kind of the amplitude of it.
The full amplitude.
Of that specific harmonic.
How loud each harmonic is.
Yeah.
Loud each harmonic.
I mean, just to clarify, like for example, the very top
one, sure.
You see it's like completely blue on one side, completely red on the other.
Lots of neural activity on the left.
That is like actually harmonic number 1.
Harmonic number 1.
Because it's like the lowest frequency, and what's happening there is that basically your left hemisphere is activated while the right hemisphere is inhibited, and then they switch. Right, so it's kind of like when you make something vibrate, the lowest harmonic is going to be something that divides the space in two. You have like, oh, this side goes up, this side goes down. So that's like the absolute simplest one, lowest frequency.
Okay.
The other ones are like more complicated. Like for example, the upper left corner. You see, it's like it has like sprinkles of red and blue. There's like kind of like this scintillating, like, oh, that's a high frequency harmonic. Like it's also doing like the up and down thing, but it's like lots of little regions that are like going up and lots of regions that are going down, and they're alternating. So yeah, that basically what that's encoding is like the frequency of the harmonic. The circle is the amplitude. And then the arrows is the degree of interference between those harmonics. So basically, if an arrow is red, that would mean that, hey, those two harmonics are very similar in frequency. And that means that they're going to cause a lot of dissonance. It's going to discombobulate the shape.
And people are going to feel not good.
Yes.
They're going to feel more pain.
Yeah, pain, discomfort, anxiety,
And more pleasure when it's a blue.
Yes.
So the graphic on the right is basically adding up all these pairwise relationships between these specific harmonics in order to estimate the total consonance and the total dissonance and the total noise. And that gives us a location in valence space, as it were.
So as in when you look, when I look on the graphic on the right, there's seems to be more, the most state potential in neutral, and then second most in pleasure, and then least most in pain. And you can see that based on the height of all of those, of the gray, the blue, and then the red. And just for completing the picture, you also have kind of like these additional like lines. That would be the spectrum of itch. So one of the kind of like sub predictions that we're making, I mean, like the big prediction is like, oh, adding up the dissonance will correlate with unpleasantness. Adding up the consonance is correlated with pleasantness. Kind of like sub predictions, which is more likely we will get them wrong, but we suspect it goes in that direction. It's basically low frequency harmonics will correspond basically with basically what's called like low arousal in affective space. So let's say you experience like a low frequency dissonance, like some of your low frequency harmonics are in a dissonant state with each other. That's gonna feel more kind of like depression
or like kind of existential discomfort, whereas high frequency dissonance is going to feel more like anxiety. So it's kind of like this high energy feeling of ill-being. Whereas if you flip it, it's like, oh, low frequency consonance, that's going to feel like relaxation. You know, this full body sense of like well-being. Whereas high frequency consonants might feel like excitement.
Like the boom, 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 yeah, party. Sure.
Right.
Okay.
Interestingly, too, this should give us a way to sort of understand or parameterize the effects of different drugs. For example, alcohol, caffeine, etc.
Yeah.
That by their effect on pushing energy into the high frequency harmonics or into the low frequency harmonics, and then also sort of pushing the system toward consonance or dissonance or noise within these frames as well.
Yeah.
And so it should really explain a lot about why different drugs feel the way they do.
Towards consonance or towards dissonance.
Right.
Yes.
And low frequency consonants or high frequency consonants.
Yes.
Consonance. Yeah. Okay. Thank you, Ron.
All right.
Okay, so can we get to just quick, I want to make sure that on the math side of things again, how does one start the process of the math again?
Yeah, well, so there's like some equations that tell you basically how to compute the dissonance between pure tones. The interesting thing is these have been like being
compute the dissonance between tones.
So take two pure tones, 400 hertz, 450 hertz.
And this is the frequency of neural activity?
Just in sound. Just in sound.
In sound, okay.
Okay. That has been pretty well studied for music theory. And it's been like empirically determined. So basically they and this actually goes back all the way to Helmholtz in the 19th century.
Because you're playing two frequencies in music, and then people get to hear. You can play with this yourself if you play the two notes, and you can say, "Wow, pleasure," versus play the two notes and go,
exactly
like that.
Yeah.
Okay.
Yeah. So you play like, for example, two notes that are like one semitone apart that is really clashing.
Yeah.
I mean, like until now, in the literature, people don't know why. We think we can explain why, but it's quite mysterious, right? It's like, why is like minor keys feel like melancholic or sad, and major keys feel like pleasant and like upbeat?
And would a dog feel that same thing, or potentially? Yeah.
Right. Well, there is music for dogs. Actually,
the answer is yes. The dogs feel it. You just need to translate the music into their vocal range, which is higher.
Vocal range.
I mean, there's a lot of projection. Humans is like, oh, why doesn't my dog love my favorite band? It's like, for them, it sounds like this low frequency garbage. You need to like translate it into something that's in their frequency range.
But do they feel a pleasure to our same ones that we feel a pleasure to in their dogs dislike dissonance. Interesting. Okay.
So just to step back a little bit, every good theory of consciousness should make a lot of predictions, should make a lot of interesting, novel, bold predictions. And so one thing we're focusing on is music, being able to explain things that are fairly mysterious otherwise. And one thing we're also focusing on, and we may have time to get to this or not, but also any good theory of consciousness should let us design better neuroscience theories, and specifically better treatments for mental health as well.
Yeah. Gosh, that last one is, we were talking about this beforehand, but just the speed at which civilization evolved, that we were unable to keep up with the watering the nutrients of the seeds of every single mind, and so now there is more of the mental health problems and more of the traumas, and so to be able to solve some of the most pressing mental health challenges with this is extremely exciting, with this cataloging. And then there's so much good work being done in the magnetic stimulation space and electrical stimulation space.
And often we see something that works, but we don't exactly know why. So our theories would explain why, for example, TMS works for depression.
Yes. Yeah, like that's that. This is what yes, why it works.
Right.
Yes.
Right.
Yes.
If you know how it works, you can improve it.
You can improve it. Yeah, and keep pushing the edge of knowledge. Okay, so just quick. So to go from sound and seeing what works in sound to applying that same math to the consonances and dissonances and noises that work in the brain.
Mm-hmm.
Yeah. I mean, like it's a lot of people who meditate a lot, for example, like do report that a lot of like the unpleasantness of experience come from like what they might call kind of like a mental turbulence, unresolved patterns that like don't look good from every point of view, and that we predict would actually manifest as like these beat patterns between the various brain harmonics. And one of the things that meditation does is purify your harmonics. So you're like canceling out those that interfere with the main ones. We also have like some work on that, but we're probably running out of time for that one.
Yeah. Okay.
One very, very important frame here is it's from business that what you can measure, you can manage. And if we have a good sort of picture into the important stuff going on in the brain, and for example, depression or anxiety or something in that space would show up in our picture into the brain in a clear way, then if our proxy is good enough, basically, if we can sort of massage these brain harmonics back into harmony, we may in fact cure the depression or anxiety.
Yeah, I love it. The massaging it back into harmony. Yeah.
Right.
Oh yeah, that's
Yes, please.
So for example,
Future of mental health.
Yeah.
Personalized harmonic retuning.
Yes. You go to in 2050 and they do the CDNS analysis and they figure out.
And CDNS again.
Oh, sorry, consonance, dissonance, noise signature of your brain. One of the things they may figure out is like, hey, like it turns out, in that diagram over there, your 17th and 19th harmonic are in a real bad, state of dissonance with each other. How do you fix that? It could very well be that there is like some obscure substance, like for example, chloroacetam. I tend to bring chloroacetam because it's a pretty understudied and very interesting. It's really, really obscure and super subtle, but it does something. And when something is like that, it may very well be that it's affecting a very narrow set of harmonics. So it could be that chloroacetam, for example, inhibits the 17th harmonic. And then like that would mean that, most people take it, they don't feel almost anything. But if you take it, you feel completely different because it was the 17th harmonic that was causing so much problem for you.
Okay.
And understanding the fine details of what's actually going on in the brain will open up a very wide array of interventions.
Yes.
Much better than take this SSRI.
Correct. Yeah.
Yeah.
The nuke approach versus the precision approach. Yeah. Okay. This is exactly. This is like we're talking just like 30 years, potentially even less. Hopefully, down the line where this is. A consonant CDNS, a consonance dissonance noise signature, is like a full connectome analysis.
That would be taking the Connectome harmonic analysis.
Connectome harmonic analysis,
which is like the mathematical object.
Yes.
And then applying an algorithm to detect the features that matter for valence.
Okay. Got it. Okay, so then you're taking an algorithm to the connectome analysis to then say this is the CDNS, the valence that the person's experiencing through the.
The analogy again might be something like you have like 4 balls moving around. Maybe the kind of like the mathematical object there is like a description of like the speed and direction of each of them. But then the temperature is taking that mathematical object and computing the average speed. And that gives you the temperature.
Okay.
So it's like that layer of there's mathematical object, and then there's like the algorithm to extract the features that matter.
Okay. Man, this is just nuts thinking about how much of this is down at the like kind of like on the chaos theory butterfly effect side of neurons being inhibited or excited.
Sure.
Because even just that 1 or 10 or 20 in that one little area going off and
One frame on that is there are these attractors in the brain that sort of
Attractors.
right,
Okay.
right. Understanding sort of the state space of the brain, and attractors are like gravity wells, and the brain
Okay.
state likes to go down in these and circle around. And so there are definitely chaotic dynamics, but there's also some level of predictability.
Yeah.
And fixing the brain that's in dissonance, for example, might be a matter of just kind of pushing it into or out of a bad attractor and into a better attractor.
Yes.
And then just letting emergent dynamics take it from there.
Okay. Yes. And that seems to be what the psychotherapy side of things really is right now, is being able to take that what is once fearful and being able to peacefully be at peace with it, and then not have it recalled over and over again, but just a peaceful integration of it. Okay. Was that it on the? Yeah, that's it on the images. Okay, cool. Yeah. Okay,
Yeah.
cool. All right. Now just a quick overall on this episode. Okay, so we're talking about the 3 S's: super happy, super intelligent, super longevity of a civilization.
Yes.
And they're needing to be children.
Yes, there needs to be children.
In Disneyland.
Yeah.
Yes.
It's gonna be somebody. I don't care if it's an old man. It's just it's the subject of
It's
experience.
beautiful for the children at play. Exactly.
Yeah.
In
Yeah,
Disneyland. Yeah.
And in sort of the futurism, transhumanism, just sort of far future frame, there are many people working toward the goal of superintelligence. And there are definitely fewer, but there are still plenty of people working toward super longevity.
Yeah.
But in terms of working toward this, even just understanding what it is, but also how to implement it, I think QRI is one of the only organizations that is working toward super happiness.
Yeah. This is again, we are seeing this across the geopolitical sphere of who's doing the AGI first, etc., and who's doing the super longevity first.
Right.
Will they share? How will that work? But that's interesting on the super happiness side of things, on understanding the valences, is who's going super on that,
Right.
and that's you guys.
Yep.
Yeah.
And I mean, consider a world without that research. I mean, in terms of
Yeah.
like, for example, big countries battling for AGI. One of the scary things here is that if you have an intelligence that basically all it's optimizing is for causal power, being able to modify the world in whatever way it allows it to make copies of itself, versus another one that is optimizing also for subjective well-being and longevity and other values, in addition to making copies of itself.
Yes.
The first one has a huge advantage, basically because it doesn't have to spend any energy on making the world better. That's something we call a pure replicator.
A pure replicator.
Yeah.
It's like taking the entire power of the star and putting it just to replication versus also to well-being, because then you'd have to siphon some of that energy for
exactly.
also the well-being.
Yes.
Yeah.
And because they have an inherent advantage, I mean, many evolutionary models would predict that's what will dominate the
Would
future.
win
So
without the children.
we are in some sense climbing uphill, modulo the fact that understanding consciousness, we predict, will also give us computational power, not accessible to those who don't understand consciousness. That said, if we don't do that fast enough, we may be overtaken by pure replicators.
Wow.
There,
That's another little race that's happening. It's not like there's enough races happening already. You have to add this race of pure replicator versus replicator with well-being.
Yes.
With valence, with experience. Yeah.
Yeah, and so just to sum up there, we think that the world will be on a very different trajectory if we figure out AGI first, or before if we figure out consciousness, or if we figure out consciousness before AGI.
Yeah. What an interesting wrap on this conversation. so cool what you guys are doing. It's so cool, and also just so cool the the theory behind it and the importance of that very abstract perspective on an evolution of a civilization, understanding the consciousness prior to developing the general intelligence being paramount. That's very, very cool. I love you both a lot. This is so powerful.
I'm gonna give you.
Oh, we got a Qualia Institute shirt. Yay. I think this is the first time we've gotten like a prize. I love it. This is great. This is also available. Is this available for people to?
It's for those who help us.
It's very exclusive at this
Very
point.
exclusive at this point. But
Roddy,
but
we're
you
so
guys,
lucky.
you guys can get one too if you get on the Let's Engineer Super Happiness train.
Yeah.
Okay, cool. So,
Not that that's like the ultimate prize. I mean,
but yeah,
there's
yeah.
Super happiness would be its own prize, I think.
Work with QRI and help out, and then you can get a cool QRA.
Yeah.
Yes.
Perfect.
Yes. Okay. Seriously, keep up the good work. We love you guys so much. Quick, just I want to ask. I think we've asked you, but I still want to. Yeah, we'll hear Mike's take on this. Are we in a simulation?
I suspect so.
Continue.
In the last appendix of Principia
Okay.
Qualia, I talk about this a little bit, and I think Andres mentioned the general structure of the argument last time. So
Okay.
I don't know if we want to get into the weeds there, but basically, two reasons to be in a simulation. One would be for instrumental reasons, or why would you ever run a simulation?
Yeah. For the
Instrumental
experiment,
reason? Sure.
For reading what the experiment said. Yeah. Okay.
If you want to calculate something, and a simulation is the most efficient way.
Yes.
Second,
will Mike Johnson pursue QRI in this simulation? Yeah.
right?
Yeah. Or will he stay in his hometown and marry the sweetheart or whatever? Right? Other travel the world, right? There's so many little tree of possibilities. Okay, yes.
Yeah. The second reason to simulate something, if you're not trying to calculate something, but the second reason is to create something that is intrinsically valuable. And so if this is the case, then we should see a lot of valuable qualia scattered around the universe. Now there's this problem of suffering where it doesn't seem like human life is all butterflies and unicorns and rainbows all the time. At the same time, if we had a formal theory of consciousness, we could sort of mindfully and formally explore this. For example, what do black holes feel like? What does quantum fuzz feel like? What does the Big Bang feel like?
Yes.
And
Yeah, that's very good.
If we find out that the Big Bang is like a super massive, super intense like
orgasm,
right.
that would be evidence that we're in a simulation.
And very
close,
testable, falsifiable.
Testing.
In fact,
We need to start probing the simulation question more effectively. I want to probe it with the scientists.
Absolutely.
Yeah. Okay, last question is, what is the most beautiful thing in the world?
Oh gosh. I think truth. That it's maybe the only thing you can build on. So I find that very beautiful.
Whose truth? Mine or yours?
The collective's truth. Yeah. And this is very good. Okay, beautiful. What a powerful number 2. Keep up the good work. QRI, everyone. Check it out. The links are below. Thank you guys. Thank you
so much.
Thank you for coming on.
This is great.
Yes, I'm glad you had a good time. We'll keep up the good work as you do more of the actual someone in an fMRI, and then also mapping out what's actually happening with their felt experience. Then we can run that data through the show and explain it to people what's actually happening.
Awesome.
That'd be great.
Yes, that will be very fun. Okay, everyone, thank you so much for tuning in. We greatly appreciate you tuning in. Give us your thoughts in the comments below. We'd love to hear from you about your thoughts on all of this crazy epicness. Do let us know your thoughts. Thank you to Ron Vargas for producing and directing. We love you very much. Check out QRI's links below. Check out Andres and Mike's links below. Go and check out their work and their blogging. And the first episode is also with Andres below as well. And support the artists and entrepreneurs that you believe in your communities and around the world. Support them, help them grow and blossom their endeavors. We need them now more than ever. Build the future, everyone. Manifest your dreams into the world. We love you very much. Thank you, and we will see you soon. Peace.